So first topic in extension is sketching different functions, all right? And what that means is if you're given a certain function, so in this case f of x represents function, and they want you to sketch basically a parabola, x squared minus 4. After that you sketch that, they want you to sketch 1 over that. So basically what they're asking you to sketch is, after sketching that, sketch. That's what they want you to sketch. Okay? So as recap, let's sketch that. Instead of writing f of x, it's the same thing as writing just y equals x squared minus 4. Same thing. All right? So from here, as usual, girls, remember from last year, if you want to sketch the graph, you need to find these two are your main intercepts that you need to find to do a rough sketch. So what's the y-intercept here? It's a number without x, minus 4. Okay? And if you want to find the x-intercept, you make y equal to 0. So you've got 0 equals x squared minus 4. And to find the x-intercept, you've got to factorize that out. In this case, using difference of two squares. Yeah, remember that?
Yes.
Yeah, so from here, x equals to 2. Here, x equals to minus 2. So let's sketch those points out. All right? So you've got 2 and minus 2. So it goes to there, goes through there, and then it has to go through there. So if I do a rough sketch, you're going to have this. All right, I'm just going to extend it a bit more. All right, so this is my f of x. Now I need to draw y equals to 1 over fx. Okay? In order to do that, let's examine a few y values. Okay? Strictly just y values only, not x values, and you'll see why. Okay? All right. From minus 4, so at minus 4, so we're looking at only the y values here. From minus 4, if you put that value and replace it here, that's 1 over minus 4. Yep? So what, and you want to get the decimal number of this, and that's minus 0.25. So our first point of this new graph, from minus 4, it actually goes all the way down to that point, which is your minus 0.25. So basically what I'm trying to do is get a few y values on the graph, and we want to see where the new point on the new graph is. Okay? Same thing. Let's see where we get if we transform minus 2. So at minus 2, so if I replace the f of x with minus 2, I get 1 over minus 2, and that is minus 0.5. So are you with me so far? So what that means, at minus 2, so this is the point where you got y equals to minus 2. At that point, it's going to go down to minus 0.5. So from this point, we're going to go down to minus 0.5. Yeah, see how that's minus 0.5? So that's my next set of points. At minus 2, it goes down to minus 0.5. Trying to be as accurate as I can. Okay, so far I've got these 3 points. Okay, I'm trying to slowly get the points of the new graph. Let's keep moving on. Let's have a look at the point y equals to minus 1. All right, so once again, if I put this point under 1, it's always going to be under 1, obviously, because that's the question, 1 over whatever the y values are. What's that? Minus 1. So, what did it do? Yeah, so that's minus 1, yeah? So at minus 1, those two are the points on the graph where it's equals to minus 1. From here, we're going to minus 1. So at that point, it stays there. It doesn't move towards anywhere else because at minus 1, if you put it under 1, it's still the same number. Okay? All right. Let's check another point. Let's have a look at minus 0.5. So at that point there, so we want to examine where the new point goes if I put it under 1. So if I put that under 1, what's 1 over minus 0.5? 1 divided by half? Minus 2. Yep. So at the point where it's minus 0.5, where does it go down to? See how that's minus 2 right there? That's your new point there. At minus 0.5, it goes down to 2. All right. We've got this so far. What does it look like so far? Upside down parabola. It's not enough information yet. I'm almost done. Okay, girls, let's have a look at the y value at 0. So this is where y equals to 0, these 2 points here. Okay? At 0, if you put it under 1, what does it become? It's an error, right? So girls, it's undefined. At that point, because it's undefined, at this undefined point, you draw a vertical asymptote. Okay? Okay, so at that point, at 0, because that's where 0 is, you draw an asymptote. And I'll do it in purple. Okay, you draw an asymptote at these 2 points. Okay, so by looking at what I've drawn in purple in the points, you can see by pattern, bounded by the asymptote, this part of the graph, if I just go by what I've drawn, it's going to be a upside down parabola. So this is part of my answer in transforming the parabola. I've transformed or reciprocated this part of the graph. Now I also got to reciprocate these 2 parts of the graph. Okay, so stay with me. Let's do this part of the graph. All right, so that's my section 1 there. All right, let's have a look at 4. Okay, let's have a look at 4. If you put, so this is the second part here. Second part, it's the first part. From 4, once again, if you put it under 1, what is it? 0.25. So at that point, it goes all the way down to 0.25. So that's my first point. From X, I'll mark it as X from where I'm going from. That's my new point right there. Okay? Let's keep moving on. Let's examine the point 2. So at 2, which on the graph is here, if you put it under 1, what is it? 0.5. So at that point 2, it goes down to 0.5. Is that, yeah, it's a bit accurate. One more point. Oh, actually, let's keep, I'm going to do 2 more points. All right. If at the point 1, which is on the graph here, if I put it under 1, what is it? 1. So at that point, it stays where it is because the value of 1 hasn't changed. Last one, 0.5. So 0.5 is there, and on the graph is here. If I put it under 1, what is it? 2. So from 0.5, it goes up to 2. Can you see by the dots that I've drawn what the pattern might look like? It's going to look like this. Okay? What I'm trying to say is when you reciprocate something, the smaller the value, the higher the value you're going to get. The bigger the value, the smaller the values and the graph you're going to get because you're reciprocating it. You're putting everything under 1. Using this same pattern here, it's the same thing. So any small value goes up and any big values go really low. The only thing that you got to make sure is at the point 1, it still goes through that same point because 1 over 1 is 1. So it's actually like this. Okay, so that's your final answer. If I was to redraw it neatly on separate, so basically you've got minus 2, 2, asymptote, asymptote, and then you've got this, and at that point at 0.5, so minus 0.5, and you've got that. This is a completely new graph that you have not seen before, and it's your typical looking graph when you reciprocate a parabola. Okay, so I know this is quite a lot, so let me write a summary note because I'm going to do another similar example like that. So, what have we learned? All right, so, notes. So, girls, these are the notes. Now, you might be wondering, how did I get these random points? I will talk about that more in depth. But the way I've chosen these values is firstly, you always want to start with the highest y value given or the lowest y value given. You want to reciprocate the highest y value and see what you get. Okay? And then this is just a random number in between minus 4 and minus 1. But the numbers you always want to reciprocate to test is the highest y value or the lowest y value, minus 1 and 0. So these are your main 3. Okay? Any other values, it's like up to you, but I've chosen minus 2 and minus 0.5 because it's just an easy number to work with. Okay?
Do you have to do 3?
If you don't do 3, it's a bit hard to tell because what we're trying to do is we're trying to get a pattern. Okay, once you get the pattern, you just follow that through. It's always going to be a curve.
Okay, but it's like not like in the test.
No. As long as you got the correct vertical asymptote points, and you've showed me the graph correctly, it doesn't have to go through specific points, but see how 1 over 1 always go through the same point? That will matter. Yeah.
So you just need the graph shape, the asymptotes, and the one.
That's right. Okay, I'm going to do the same thing with another parabola example. So I know this is quite overwhelming at first. So let's go through one more. But make sure you take a photo of this before I move on. That's the part I need you girls to take a photo so we can just keep moving on. All right, so girls, whatever you label down here, you also want to label it up there. All right, make your space relatively the same. If you have a graphing paper, obviously that's even better. And as you can see, 0.5 is a useful also value to have. That's the reason why I had 0.5 in the beginning, okay? Because you want to manipulate and transform small values to see where the big value is. With the X-intercept values, you usually don't know. So, okay, to be safe, let's do our usual. What's the Y-intercept and the X-intercept? Well, that's -4. Now, with the X-intercept, you've got to factorize negative out. So we've got minus x squared. Oh, I think this is see, they made a typo. It's meant to be +9. See, that makes sense. You can't factorize it. Let's make the question that. Yeah, let's change the question. All right. All right. So in your exercise, instead of -9, you should say +9.
It's +4 the way.
Oh yeah, now it's +4. Thanks. Yeah. All right, we can factorize that. So that's minus x minus 2.
How would you do it if you couldn't factorize it?
If you couldn't factorize it, you can use quadratic formula, but you may not get a solution. So that means there's no X-intercept. Usually don't get that kind of question for this type of question. All right, so am I right so far? Just point me out if I make any silly mistakes. All right, no. So far, now, see how my X-intercepts are 2 and -2? That means you want here 1 and -2. All right, that's enough for me to set it up. Are we good? Let's get to it. Upside down parabola, because there's a minus in front of x squared, +4, and it has to go through these two. So these 3 points. All right, so we got that to transform. Okay. First step that I always that I would do is draw. I'm not gonna write it out. That's my number 1 step. All right, I'm gonna draw vertical asymptotes at the X-intercepts to start off with. That's the easiest way to start.
Is it always the X-intercepts?
Always the X-intercepts. Yep. So the X-intercepts are here and here. Draw vertical asymptote. Okay. Now, second step, looking at the highest y value. In this case, it's, what is it? 4, and it becomes 1 over 4, and that is 0.25 again, like last time. So at 4, it goes down to this point. So okay, so x marks where I'm starting. The dot represents where the final point is. Okay. Now let's have a look at what's my next point that I usually like to go with. 1, because at 1, it's going to stay at that point. Yeah, because 1 over 1 is 1. Yeah? Can you already see a pattern coming? If you knew this exercise well enough, you would know these 3 points are enough to confirm it's just going to be a parabola at that point. Bounded by, because you have to draw a curve bounded by these 2 lines at the points you have. So the early graph that you can make out of from what you just drawn. Yeah. A forced parabola. Okay? But just to confirm, let's pick the number 2. So at 2, if you put it under 1, what is it? Half. So at that point 2, it goes down to half, which matches, close enough. Yeah, 0.5. That's where it's meant to be at 2. So at 2, it goes down to 0.5. So this confirms that it's going to be a parabola in that section. Right, section 1. Okay? Now let's do the same thing for these outside sections. Okay? So the value that I will once again start with -4. if you put 1 over minus 4, it becomes negative 0.25. Yeah? So at that point, we're going to go all the way down. As you can see, that's my point there. The next point that I'm going to play around with, again, is just another point. Let's try minus 2. At minus 2, if you put it under 1, what does it become? 0.5. So which is just slightly above the point I did before. And the next value you want to play around with 1 is because 1 over minus 1 is 1. Can you see what we're going to be drawing? Okay, so it's going to be like what we did before. Okay, and this makes sense. Girls, the reason why it's really high here, girls, if you had minus 0.5, if you had minus 0.5, and then you put it under 1, what does it become? Minus 2. So that's why you can see for really low values, it becomes high. But for really big values, it becomes low. Using the same pattern, it's going to look the same here. But the only point that you need to make sure that it goes through is 1. Okay, so there's...
Isn't it reflected on the other side anyway because it's an even function?
That's right, but that's for next time. Yep, so this is generally what reciprocating parabola graph is going to look like. It's usually always going to be like what we've done before. It's going to be like that, or it's going to be like... all right, it's going to be like one or the other, all right? So take this as a general fact.